So today we're going to be talking about chords, congruent chords to be specific. There's a lot of things that entail a circle. And as we know, a chord is not a diameter. A chord is a segment that goes from one endpoint of the circle to another endpoint of the circle. So AC here would be a chord, and DF would be a chord. Now, chords and diameters are totally different things. A diameter is a chord that happens to go through the center of the circle. But if a chord does not go through the center, it is not a diameter. It is simply a chord. So, what are we talking about here in relation to chords, not diameters? If two chords of a circle are equidistant from the center, then they are congruent. Now, if you noticed, I color-coded the red with the red and the blue with the blue. And what it's saying is, if OB is, and I should have made that blue, sorry about that. Let me make this blue here right quick. Fix that up. Not bad, thank you. Okay, so if OB is congruent to OE, they're equidistant from the center, then, guarantee 100%, the chord AC will be congruent to the chord DF. Now, I went ahead and created a shortcut for this proof, for this theorem. And we're going to call it the center chord equidistant theorem. The center chord equidistant theorem. Actually, let's make this equidistance better. Equidistance theorem. Okay. So again, if the distance from the center to the chord are congruent, then the chords are congruent. All right? Next theorem. If two chords of a circle are congruent, then they are equidistant from the center of the circle. Absolutely. So in this case, if AC is congruent to DF, if the chords are congruent, then the distance from those two chords to the center are congruent. And here we can shortcut this and call it the converse of the center chord equidistant theorem. Remember, guys, that the converse switches the if and the then. So if I have the conditional statement, if P then Q, remember that the converse would say if Q then P. So that's why this is the converse here. So you have Theorem 77, which states again, if the distance, okay, two chords of a circle are equidistant to the center, then the chords are equal. And then you have, if two chords of a circle are congruent, then their distances from the center are congruent. They are equidistant from the center of that circle. Does that make sense? Oh, okay. Awesome. Go ahead, sir. We have a question? I think what he was asking was, he says, do they have to come from the same, and he stopped. I believe he means like, can it be like from here to here and here to here? Would those two be equal as well, guys? No, wrong. Okay, because first of all, guys, we have to remember that in 10.1, we defined the distance from the center to the chord to be an altitude. Did we not say that? It had to be an altitude. So this black line here, this guy, right here, that is not the distance. That's a hypotenuse. This is not a distance, that's a hypotenuse. So when they're talking about the distance from a chord to the center, they're talking about that segment that is a perpendicular bisector to those chords. And that's it. There's no ifs, ands, or buts about it. Yes, sir. Okay, he asked me a question, a hypothetical question. If AD is congruent to what? If AD is congruent, first of all, there is no AD here. There's an arc AD. So he's asking me if that's congruent to what? How could AC be congruent to AD, son? Okay, I'm going to ignore this question because it's not very good. I do apologize out there in computer land, but that was horrible. Okay, so let's use these theorems in the problem. Given circle O, they tell us that AB is congruent to CD. They say that OP is 12x minus 5 and that OQ is 4x plus 19. Well, let's look at what they've given us and let's look at what we need to find. We need to find OP. So how do we do this? Okay, I had like 7 people tell me the same thing. What they all said correctly was, well, since AB is congruent to CD, so you have two chords within the same circle that are congruent, that means they will be equidistant to the center. So OP must equal OQ. So I got 12x minus 5 equals 4x plus 19. I've got 8x equals 24. So x equals 3. So what would OP be? It'd be 36 minus 5 equals 31. Now, there was a student who said OP would be 3. Be very careful here. This is what x equaled. X equaled 3. But then you must plug that in to the equation of OP. Okay, so just be careful with that, guys. Now, let's try a proof. Let's try a proof. Okay, we got the following. We got the following here. Let me see something. All right. Let's try this problem now. Here we have the following givens. ABC is an isosceles triangle with base AC. So, okay, of course, that's simple enough. Given. Next, we have circle O. We have PQ is perpendicular to AB. We got PR is perpendicular to CB. And all that is given as well. All right. Now we have a lot of information here. Okay, we've got a lot of information, so let's see how we can use this. Since we know that PQ is perpendicular to AB and PR is perpendicular to BC, what can we know from that? What do we know from that? That they're congruent. Who's congruent? That PQ and PR are congruent? No, that's wrong. That AB is congruent to BC. The theorem states that if two chords of the same triangle are congruent, then they are both equidistant from the center. Okay? So all we know is that's a perpendicular. It's perpendicular. Okay? So CB is going to be congruent to BC. Yes, sir. Okay. Now, next. PQ would be congruent to PR. Why? Because of the converse of the center chord equidistant theorem. And then my last final proof, yeah? My last final proof. PQR is isosceles. Definition of isosceles. Yes. Yes, sir. Your question, sir. Okay, what is your question now, son? Go ahead. What's your question? Okay, he's asking PR can be perpendicular to any line. Yeah, and? I don't understand your question. PQ being perpendicular to AB and PR being perpendicular to CB means that PQ and PR are going to be the distances from the center to the chord. AB is going to be congruent to BC because definition of an isosceles. And then once AB is congruent to CB, then you know that PQ will be congruent to PR because it won't be same as the above, but it would be the converse of center, chord, center, chord, equidistant theorem. Okay? Your homework is valid. Have a great day. God bless you all. Bye-bye.